Mathematics 2, Chapter Integration. Tutorial question 23. Let's try to do A. Note that d dx of x squared over 2 will give you x as the result. Find all antiderivative of fx, where fx is equivalent to x. Now, let's try to look into this information. Now, originally, you have x squared over 2. However, when you perform a differentiation, which is d over dx, you will obtain x as a result. This x is written or denoted as your fx. However, it's basically the derivative of your x squared over 2. Let's put this as y so that you do not confuse. Now, what is meant by antiderivative? Antiderivative is the opposite of differentiation, which is the integration. Correct. Reversing the process. You want to integrate your fx, meaning you reverse the process. You're going to integrate fx with respect to dx. So very simple. So A is basically you integrate fx with respect to dx. What is your fx? Which is x. Integrate x will give you x squared over 2. However, since your integration is indefinite integration, you always need to add in the arbitrary constant c at the end. So this is the antiderivative of your fx. Now, how to do B? Graph your antiderivative, which is this function. If the function passes through 0, 0, as well as 0, 1 and 0, 2. So basically, they give you different coordinate. When they give you different coordinate, you might obtain different value of c. So let's try to find all these three functions. Let me erase the working step at the top, and then we rewrite back the solution for B. So we know already the antiderivative of our fx just now denoted as your y, x squared over 2 plus c. So if let's say it's passed through 0, 0, what will be my c? Now let's try to do it together. 0 equals to 0 squared over 2 plus c. At the end you got c equals to 0. If let's say it's changed to 0, 1, correct. It will become 1 equals to 0 squared over 2 plus c. At the end, you will got c equals to 1. And last but not least, if you substitute the coordinate 0, 2, you will got a c value of 2. Hence, you have three different functions. y1 equals to x squared over 2 plus 0. y2 is x squared over 2 plus 1. y3 equals to x squared over 2 plus 2. Now, once we obtain the function, we will try to sketch it as what is the question B asks you. Now, very simple. This is just a quadratic. I believe all of you have learned how to draw a quadratic function. So the first function is just simply x squared over 2. So it's going to pass through origin. So this is going to be your first graph, y1. Now the next one, I'm going to use different color. It's going to pass through y equals to 1. Y, if you notice, this is going to be our y-intercept. Okay, so the second graph will pass through y equals to 1. Last but not least, correct, is going to pass through y equals to 2. So this is basically the answer for B. Now, what is C? How are the graph of these three antiderivative in part B are related? Yes, it is very much related. It's actually your antiderivative changing depending on the value of C, and C was obtained through the condition given. However, it's exactly the same except the y-intercept. So every time C change, your graph will move up in your y-axis. Hence, we say that your antiderivative is having a translation, vertical translation. Why vertical? Because of y-axis. You can just write vertical translation in the y-axis. That's all for 23.